All right, let's look at number one. The figure below shows histograms for several binomial distributions with n equals 6 trials. Match the probability with the best graph. So the p equals zero point 0.3. So let's think a bit about this. The x-axis where it goes from 0 to 1, okay? And so if p equals zero point 0.3, where would the peak be at on the graph? Would it be on the far left, kind of middle left, middle right, or far right? Where do we think that, where would point 0.3 be at on the number line if I'm talking from 0 to 1? See, point 0.3 would kind of be in this area, right? Point 0.3 would be there. If I'm going from 0 to 1, point 0.3 is kind of in this area. So it's going to peak around kind of the middle left. So that one should be 2. What about point 0.5? So point 0.5, where is point 0.5 on a between 0 and 1? That'd be right in the middle, right? So it should peak right in the middle if the probability is 0.5. 0.65, where would that one peak at? So that would kind of peak. 0.65 is in this area, so it should be peaking around the middle right. So that would be 3. And then the last one I can't see, 0.9 would be peaking at around 0.9, which is close to 1. So it'd be peaking over here. Okay. Now we talk about skewness. Skewness is where the tail of the graph is at. So when you're talking about 0.5, is there a tail on it or is it roughly symmetric? Is it, if I fold it in half, it'd be about the same on both sides. So if I fold this in half, would it be about the same on both sides on the 0.5 one? Yes. So that one is roughly symmetric. Okay. But as I get closer to 1, for example, these two get closer to 1. Do they have a tail on their graphs? Do they tail off a certain way? You see they tail off this way, they tail off to the left. So we say it's skewed left. We say it's skewed left because the tail of this graph is on the left side. So as it gets closer to 1, it's skewed left. What happens when it's closer to 0? So this one's closer to 0. When it gets closer to 0, where's the tail at? The tail is on the right. So when I'm closer to 0, the tail's on the right. So it's closer to 0, it's skewed right. When I'm closer to 1, it's skewed left. So closer to 0, close to 1, it's skewed left. Closer to 1, it's skewed left. Closer to 0, it's skewed right. So close to 1, it's skewed left. Close to 0, it's skewed right. Okay. All right. So there's your number 1. All right. Let's look at number 2. So we kind of saw this in our notes. So this is kind of similar to what you saw in your notes. In Hawaii, January's favorite month of surfing. 60% of the days have the surfing at least 6 feet. You work day shifts at Honolulu emergency room. At the beginning of the month, you select your days off. You pick 7 days at random to go surfing. Let R be the number of days you surf that's at least 6 feet. So make a histogram. Guess what? Salt will do this for you. Recall in our notes that we had to do the histogram by hand. Okay, we had to do it by hand in the notes, but Salt will do this for you. So here's how you do it. You click on Salt. On distribution calculators, you're going to click the binomial distribution. Okay. Now, the number of trials. The number of trials represents the number of days that you go. So you pick 7 days to go at random. So it's going to be 7 days. So your number of trials you're in is going to be 7. Or for me, it's going to be 7. Now, P is your probability of success. The probability, or I guess in this case, the probability that the surf is at least 6 feet. So 60% of the days is at least 6 feet. So my probability is going to be 0.6. I don't have to worry about this right now. I'm just focused on the graph. And so my graph is going to look like this, okay? So it kind of peaks around. I'm going to move this out, see if I can zoom out a little bit. Kind of hard to see. So you could see it's a little skewed to the left, okay? It peaks around there, 4. It peaks around 4 there. Okay, it peaks at 4. It's a little skewed to the left. Let's see if we can start to eliminate. I did not mean to click that. So it's skewed to the left slightly, peaks at 4. So this one peaks at 4. I didn't mean to do that, but that actually is the right answer. So it peaks at 4. And, it's that 0 is, barely on the value there. 1 is at 0.01. So you see that matches with that. 2 is at 0.077. So that matches with that. 3 is at 0.19. So it's close to that. So you kind of can match those frequencies there, or match those probabilities there for the probabilities for R. Okay. We will use SALT again. What's the probability of getting 4 more days of surf when it's at least 6 feet? So now we're going to do a probability. So now, 4 or more, is that an exact value? Is that meaning 4 and above, or is that meaning 4 and below? What does 4 or more mean? 4 or more means 4 and above. So if you're talking about a number and above, what do you use in the binomial distribution? Is that a left tail, a right tail, or equal when I'm talking about above? Which way would be above? Is left above or right's above? Right's above. Now, the next question I have to ask is 4 or more. Does that include 4? Is 4 4 or more? Yes. So I'll include 4 whenever I do put my value in there. So it's right tail because it's 4 and above. And I include 4 because it's 4 is included because 4 is 4 or more. So this is my probability. How many decimal places? Round to 3. Okay, so 3.710. Okay. Now be careful on this next one. What's the probability of getting 3 days, fewer than 3 days? So fewer than 3, is that equal to 3, below 3, or above 3? Fewer than 3 is below 3. So when you're below, you're talking about left tail, right tail, or equal? Left tail, because left tail is below. Because if you're going left on the number line, you're going below. So 7 is the fixed number of trials. Probability of success is 0.6, but the temptation is to put 3 here. But is that correct? Fewer than 3. Is 3 fewer than 3? 3 is not fewer than 3. So I do not include 3 in this. I have to go 1 below this. So fewer than 3 would be 2 and below. So what I have to do is I have to subtract 1 from that number. So subtracting 1 from that number would be 0.096. Okay. I'm going to move this over. Now, the next question asks, what's the expected number of days? What is that referencing? The expected number of days is a reference to the mean. It's the mean. The expected number of days is the mean. So to find the mean, I just do n times p. N is the number of trials. Okay, let me get this zoom off. N is the number of trials, so I have 7 days. So I'm going to put 7 times the probability of success. Probability of success is 0.6. Okay? I believe right. Let me double check that. 0.6, yes. So 7 days, that's my number of trials, and then 0.6, and that'd be 4.2. Okay. What's the standard deviation of the R probability distribution? So the standard deviation is the square root of n, which is 7, times p, which is 0.6, times q. What is q? Q is 1 minus p. What's 1 minus 0.6? 0.4. Okay, so you get 1.29. How many decimal places do we want? 3. 1.296. Okay, so that's the standard deviation of the R distribution. So let's kind of talk through this last part. Can you be fairly confident the surf will be at least 6 feet high on one of your days off? So let's talk about this. Let's first go at least 6 feet high on one of your days off. On at least 6 feet high on one of your days off. So I need to know the probability at least once. I'm going to go back to SALT. I want to talk about the probability that I have 7 days off. I want at least one of them to have a surf that's got a higher than 6 feet. So at least one, is that equal to left tail or right tail? Let's think, is that above, at least one above one or below one? At least one's above one. So it's going to be a right tail. And I've got 7 days. My probability is 0.6. I'm going to put at least one. I'm going to put 1 there. I want to know the probability it's at least 1. So that means that on my 7 days off, at least one of them is going to have a day where a good surfing day. So it'll be 0.998. So would you be pretty confident you're going to have at least one nice surfing day? There's a 99.8% chance you'll have at least one day. So you pretty confident about that? Yes, because the probability of the surfing day at least 6 feet, or one day of at least 6 feet, is 0.998. And the expected number of days that surfing at least 6 feet is greater than 1. So the expected number of days is 4.2. So if you have 7 days off, you expect at least around 4.2 of them to be able to would have the nice surfing days. And so the probability of having at least one day, you're very confident you're going to be able to have at least one of those days off where it's going to be a nice surfing day. So that's kind of how we would approach that. All right, 3 is going to apply a little bit of the probability distribution of the binomial, but also the mean and standard deviation. All right, so let's look at A. If 15 people, all right, first off, let's read the question. Have you ever tried to get out of jury duty? About 25% of those called will find an excuse to get out of jury duty. If 15 people are called for jury duty, what's probably that all 15 will be available? Okay, let's talk about this. We've got salt available. We already got salt. We're going to do binomial. 15 people are called, and all 15 will be available. Now, let's think about this. First off, if all 15 are available, is that a less than, greater than, or is that equal to all 15? That's an equal to. So I'm wanting to know the probability that all 15 are available. Now, we need to discuss the probability, though. Okay, we need to discuss the probability. So 25% will find an excuse to not be there. So we're talking about who will be available. So what should our probability be? These 25% are not available. We're talking about available. So our probability is going to be 0.75 or 75% because we're wanting to know the probability they're available. Okay. So we want to know the probability they're available. So 0.013. So I have to change that probability to use the complement because I need to know the probability that they're available. Okay, now it's going to shift gears on us. If 15 people are called for jury duty, what's probably that 9 or more will not be available? 9 or more will not be available. So 9 or more, is that left tail, right tail, or equal? 9 or more. Is 9 or more above or below? Yeah, right tail, above. Good. 9 or more. Does 9 or more include 9? Yes, so I include 9 there. Now, here's the trick. What are the probability 9 or more will not be available? So what probability am I working with? Am I working with the available one in 0.75, or am I working with this 0.25? 0.25, because the 0.25 is the probability that they're not going to be available. So I have to use that probability. Okay, so you have to be careful there on how you approach this. We'll move this over here. Now, find the expected number of those available to serve on the jury. So now if I'm talking about the expected number available, first off, expected number. Expected number is just a reference to the mean, mu. Expected number would be my number of trials, 15, times the probability that they're available. What would be the probability they're available? 0.75. So 0.25, they're not available. So 0.75, they are available. So 11.25. What's my standard deviation? I'm going to go to square root. I believe this is 2 decimal places, so be careful. N times P times 1 minus 0.75. 1 minus 0.75 is 0.25. 1.68. Okay. Okay, D is a little tricky. What's the smallest number of people that a jury commissioner must contact to be at least 95.9% sure of finding at least 12 people who are available to serve? Okay, so let's talk about how we're going to use SALT to manipulate this for us. The smallest number of people, N. So we're solving for N. So N is what we're going to be adjusting to have at least 12 people. Now let's think about at least 12. At least 12, is that a left tail or right tail? At least 12. Is that above or below 12? That'd be above. So it's a right tail. At least 12 is above. And does at least 12 include 12? Yes, at least 12 includes 12. Now, what I'm wanting to know is the probability that are available. So now I'm going back to the available probability. The available probability is 0.75. Now, here's what you have to do here. This is not too bad. You can click on N. We're going to see how many people I need to have for this thing to be greater than 0.959. I want to click up, and the first value of n that makes this greater than 0.959 will be my answer. Still not above 0.959. Still not above 0.959. Still not above 0.959. I'm getting closer. Right now, oh my goodness, I'm barely above 0.959, 0.95907, barely above it. So I click on the end, I click up until I get reach across 0.959, and I do that at 20. So I would need 20 people. So that's a simple way on SALT to do that. We did that on our notes by using binomial CDF, working with the complement, and that's just a lot easier using SALT for that. So